to do game development in just plain JavaScript. Okay, so also I want to thank everyone here for showing up. It's brutal out there. You guys are pros. For those of you who decided to stay safe out there in Twitch land, that's probably the smartest idea too. You just won't get a chance to get any of these awesome shirts today. I'm throwing out shirts today. Okay, so that's me. I'm the code boss. Also, I've got this timer down here at the bottom, up at the top. Looks like I may need battery here in a second. Jesse's going to give his talk after mine. I want to make sure I don't impede that by going over. So if it gets to be about 12, I'm going to try to start wrapping it up like right then. So if it doesn't look like I'm ending something at 12, please yell at me, because we want to give the man of the hour his due time. Okay. Make sure I got do not disturb on. Good. All right, so I work at a company called Clevyr. We are a consulting company. We are here locally. We do all kinds of projects, a lot of data-driven projects for local clients. It's a lot of fun. You've probably heard me talk about Clevyr a lot. The first question I want to ask is we created a new company last year that I'm sure many of you know about. If anyone who does not have a shirt yet knows what that company is, you get a shirt. Anyone know? Joe. Do you have a shirt yet? Okay, Joe gets the first shirt. All right, I'm just going to throw these out. I've got different sizes, not necessarily with me, but if I give you the wrong size, then let me know. We'll work it out. Okay, Clevyr Labs, bingo. That's the second company, and we've been doing a lot of virtual reality, augmented reality development, a lot of game development, which is kind of why I wanted to get into game dev. So it's a lot of fun, and we are hiring too. So if you want to work for Clevyr, potentially with getting into Clevyr Labs too, check us out, clevyr.com careers. Just a small pitch. I've got a couple more questions for shirts later on that actually have to do with tech things. But before we get into this, today's a very special day, and it's obviously OKC.js Day. But it's a very special person's birthday here, and I think we should owe him the honor of a good round of applause. So on the count of three, we're gonna not a round of applause, a happy birthday song. That's what I meant. On the count of three, everyone. 1, 2, 3. Happy birthday to you. Happy birthday to you. Happy birthday, dear Jesse. Happy birthday to you. And Jesse gets one of our newest shirts. Bam. Wheeler District shirts. That's going to be what I'm going to throw out later. So.
Awesome. Happy birthday, man. No one's ever done that, but happy birthday.
Congratulations. You did it. You did it. Okay. I've wasted enough time. Let's get to some game dev talk. Okay. So this is all going to be coded. I had originally planned to make this live coding, but there's not a ton of code, but it's more than I wanted to do live coding. So we're going to jump through different code. I'm not going to code it on the fly. But before we get into that, let me go over my principles of game dev. They're mine because they're common ones, but they're also not official. So kind of 4 things. The top 2 are the really most important ones. With game development, you have what's called the game loop, which can be called the main loop. You have some type of looping construct that's always asking, hey, what happened? Did someone press a button? Did someone press a button? Did something happen? Like, what do I need to do on this next frame? That's constantly happening in game development, and you'll see that from the very first block of code I show. Second thing is handling user input. Goes right with that game loop. You're constantly asking what changed? What do I need to do now? Was a button pressed? Was the mouse clicked? Was the mouse moved? Did something collide with something else I need to handle? Which is not technically user input, but it could be if you pressed a button. And then the second 2 are there's a lot of variables involved with game development. You have to track the kind of the state of a lot of different things. So you'll see a lot of variables today in this. And then math. I remember when I was learning about programming, it was constantly told that you're going to use a lot of math when you're programming, and I never use math. Like, I add things, and sometimes I do like modulus division, simple stuff. With game development, and maybe I'm just not in the right field, I don't know. But with game development, there's a lot of math all the time, and you're going to see, not crazy math today, but more math than you would do with normal programming. So, without further ado, let's do a demo, and this is going to take the majority of the rest of the time. So we're going to build single-player Pong, and the way we're going to do this is I've got a main HTML file here. It's all going to be just canvas-based. Can you guys see this all right? Do I need to zoom in at all? Okay, if anyone can't see it, by all means shout out. We've got it's the basic index HTML file here, nothing crazy going on here. The big thing is we have this canvas thing here. This one looks like a funky line. Don't worry about this. This is just a fancy way for me to load in a different JavaScript file based on what port I'm on, because we're going to dig through these 10 files right here, and they build on each other. So that's just a fancy way of me saying, all right, so if I'm on port 7000, for example, load up the app-0 file. Nothing to worry about. Nothing related to this talk at all. So we have our index HTML file there. We're not going to change that. The only important thing to note is it's got a canvas on there, as you can see right here. So let's make single-player Pong. And the idea behind this game is we're going to make it to where a ball bounces around this area. It's going to bounce off of this wall, this wall, this wall. And we're going to have a paddle at the bottom that we use the left and right keys to move back and forth that behaves as Pong. If we miss the ball, it goes down here. We're just going to refresh the page. That's our losing game thing. It's a very simple losing algorithm. OK, so the very first thing, we're just going to create kind of our scaffold here. Very short. We've got 10 lines here. We get our canvas here. We just get it. And there's no libraries at all involved with this. No jQuery, nothing. Just core JavaScript. So we're going to get our canvas element by the ID, my canvas. And in this line, we're going to get the context of the canvas. This is important because you can get different contexts of a canvas. We're getting the two-dimensional context, which changes how we use it. You can get WebGL context. You can get WebGL2 context. And I think you can get bitmap renderer context. So anything we do with the canvas, we're going to use this context for right here. And then the next thing, we're just setting up our game loop here. Now, I'm using something here called request animation frame, and you'll see that I did not define that function. You may also know that this is a JavaScript native thing. I don't have to define that because it's a thing that JavaScript has. Second question, where you can get a shirt just like Jesse had with the Wheeler District shirt on it. Who can tell me what request animation frame actually does? Yes. Yes. Bingo. Request. I'm going to throw you a shirt here. If it's not the right shirt, let me know. We'll work it out. Boom. I also knock things over when I throw shirts. So John's absolutely correct. Request animation frame. The idea is the next time the browser is ready to update, if you call request animation frame, the argument here is a function. It will run that function whenever the browser is ready to update. And the idea with the request animation frame, it only gets run once. You want to kind of have a recursive algorithm going here where your callback is ideally going to call request animation frame again. This is kind of our game loop here. There's another way that you could get a game loop going with JavaScript, and that's just with set interval or constantly calling set timeout. Those are kind of seen as not as optimal because the way those work as far as the JavaScript call stack goes, they can get bunched up to where a lot of them may fire at a certain time. They don't necessarily fire every interval. And request animation frame is in a way like that too, but you're letting the browser decide when it's ready to update. It usually happens right before the screen repaints. It usually runs at about 60 frames per second ideally, so this is going to get called 60 times a second ideally. So anyway, it's a solid way to do your game loop. So nothing crazy going on here. We just have a function, draw. It's not doing anything. It's just going to call itself again. So that's what's running right here on port 7000. Nothing's happening, but this draw function is getting called a lot, continuously. So let's dig into how we can actually do something with this. We've kind of set up our game loop here, just pure JavaScript. OK, so more code. I've tried to kind of section off what's new and what's not new. And it's going to look like a lot, but we're going to walk through it all. Don't worry. So we've got some new code here. Let's just render our ball, first of all. We've got some variables. I told you we're going to have a lot of variables. So x and y are going to represent the center of our ball. So this ball is going to be at the canvas width divided by 2. That's just going to be the middle of the screen. It's going to be the canvas height minus 30 for the y, which is going to be all the way down minus 30 pixels. So its ball should be kind of around here. And that's just the starting position of our ball. And then we just set a ball radius of 10. That's 10 pixels. We can change that to get a bigger ball. And then in our draw function, I'm going to skip over the draw ball function. In our draw function, we call draw ball, which going back to that, this is how we create a shape using a two-dimensional canvas. We're going to begin the path. To create a circle, you create an arc. The arc arguments go as the center of the ball, so x, y, that's your center of the ball, the radius, And then these next two are the start and the end of the arc. If you remember geometry from back in high school, a circle starts at 0 radians, and then if you go all the way around it, you're at 2 pi r, so 2 pi radians. So that's what this fanciness of math.pi times 2 is, geometry. The fill style here, you can say blue, you can put hexadecimal, you can put RGB values, it doesn't matter. Anything that works in CSS colors works here. We're going to fill this shape, and then we're just going to close it. So this is just, you're going to see this one more time when we draw the paddle later on, but this is just a simple shape drawn with canvas. So let's jump to port 7001. Boom, we got a ball. If you look closely, it looks kind of like an octagon, and I think the only thing I can think of is that must be a browser optimization thing, because even though it doesn't look like it, we're constantly drawing this ball over and over again because it's in the game loop. So you'll notice when it starts moving, it does not look like an octagon. Okay, we've got a ball. We're like 10% of the way there, winning. Okay, let's make the ball move. So the way we're going to do that, we're going to hop over here. We've got a couple new variables. I'm defining a dx and a dy. For you physics guys out there, this is delta x, delta y. That's the change in position of the ball with the direction, so it can go in a positive or negative direction. So we're just going to, the idea with these variables is that we're going to say every frame, we want the ball to go right 2 pixels and to go down 2 pixels. I'm sorry, to go up, because, yeah, down is positive in the canvas, up is negative. Okay, so let's use those, and the only way we need to use those is on every draw function, or in the draw function, we're just going to update the center of the ball to update it by the dx, dy. So dx gets added to x, and dy gets added to y. Well, this looks like we're adding dy. Keep in mind that right now dy is a negative value, so we're subtracting it. And those values will change. dx will eventually become a negative value later on. So nothing crazy going on here. Let's check this out. So we should have a ball bouncing around right now, or at least going in a direction. But wait, it's doing that. Why is it doing that? That's not a ball. Let's refresh again. It's just drawing. It's drawing the ball, but it's drawing it over and over again on top of what was previously drawn before. So what we need to do is we need to clear the canvas every time a new frame happens. And this is a common thing. You want to wipe out what you don't need anymore. Wipe out what's been changed, and then you are overriding it. So let's do that. This is going to be the easiest change right here. It's just a single line. We're just going to tell the context of the canvas to clear from the top left corner. That's those first 2 arguments, and then we're going to say the width of what we want it to clear, which happens to be the canvas width, and then the height we want it to clear, which is the canvas height. So we're just wiping out the entire canvas every single time. So as you would expect, we now are going to have a ball bouncing around. Look at that. Oh, sorry, it's not bouncing yet, but we at least have it moving around. Okay, the bouncing comes next, though. So with single-player Pong, we want it to bounce off of every surface except for this bottom surface right here. So let's do that. We're going to learn a little bit how collision detection works. And this is kind of the eye-opening moment for me, because I always assumed something like collision detection is something that, I don't know, I thought it was more, I thought it was deeper than what I don't know, than what it actually is. And it's not. It's literally just very simple math of, is the ball over here? Like, is it going to go over to this side? Is it going to hit the top? But I've talked enough. Let me actually show you kind of what it looks like. Let me see if we have any new variables. I don't think so. Okay. So this is all it takes right here to get the ball to bounce off of all of the walls except the bottom wall. Let's start off with the top one here. So we're going to check to see if the center of the ball plus where it's going is greater than the canvas width minus the ball radius. That's checking the right boundary right here. So if the ball's x is somewhere over here, but if it's greater than the canvas width minus the ball radius, because we want to take into account the ball radius, that would mean that the ball has to be over here somewhere. So if that's true, then we just want x to change direction. It can be the same dx, just needs to be the negative version of what it is. So if it's going, right, now we want it to go left. So that's the right wall. Or if the radius of the ball plus, the center of the ball plus where it's going in the next frame is just less than the ball radius, which means because the canvas, the position would be 0 over here, we just need to account for the ball radius, that would mean it's over here. So if it's less than this, that means it's beyond this wall or about to be beyond the wall, so we need to change direction again. And then y, we would do the exact same thing down here, except it's even easier because we don't need to track the bottom wall. We want that one to be open-ended. So we just check the top wall. So if the y of the ball, which is going to be, it's going to be 0 up here, if the y of the ball plus where it's going is less than the ball radius, that would mean it's beyond this top wall here. We want to change the y direction. So just 2 if statements, nothing crazy. And let's see if we can get some bouncing. Boom, boom, we did it. We did it, everyone. We're not going to see it bounce in the other wall, but you can rest assured that it did bounce nicely down here. You can we'll just pretend. Okay, so we've got a bouncing ball now. And we just did some collision detection. It doesn't sound like much, but this is the basics of collision detection. You're just detecting, is the state of this thing, beyond or at the state of this other thing? That's it. And then if it is, do something. And we're just changing the dx or dy directions. That's it. Okay. Now, let's draw the paddle. We're going to draw it the same way that we did with the ball, except it's not an arc. It'll be a rectangle. So we're calling a draw paddle function in our draw function. There's nothing else new down here. That's going to call this function up here. But before I dig into that, we did define some new variables. Let's jump up and see what new variables we have. We define a paddle height of 10 pixels. We define a paddle width of 75 pixels. And then we define a paddle x variable. And this is the variable that will track the x location of our paddle. Because when we move it left and right, we need to know where it actually is. We don't care about the y because our paddle is going to be locked at the bottom of our canvas. And it's never going to go up or down. This isn't crazy Pong. This is just normal Pong. Okay, so we've got some new variables here. In the paddle x, we're just going to set it initially to the very middle of the canvas, which we're going to take the canvas width minus the paddle width and then divide that by 2. If we just took the canvas width divided by 2, it would be kind of off-center to the right side. Okay, so we've got some variables here. Let's draw the paddle. I won't dig into this one as much because it's very similar to the draw ball function up there. The only difference is this rect right here, which kind of like clear rect, it accepts 4 arguments. It accepts the x value where you want to start, the y value where you want to start, and then the width and then the height of your rectangle. So we've got those locked in variables. We're good to go. Let's see what this looks like. Boom, we've got a paddle there. But we can't, it's real pretty. It's nice and red. We can't move it though, and even if the ball were to hit the paddle, it wouldn't do anything because we're not detecting any collisions on it. It's more or less just a background image right now. It's just sitting there. So let's make it move. We got to do 2 things. We got to make it move, and then we got to do some collision detection. So let's make it move first of all. And this is probably going to be the page that has the most code. Let's stop at the top, but it's nothing crazy. It's just event handlers. So starting with some new code here, we've added a paddle dx. That means every time we press one of the arrow keys, left or right, we want the paddle to move 7 pixels. We have a variable tracking if the right key is pressed and if the variable tracking if the left key is pressed. So we're going to add 2 handlers down here. I'm going to scroll down a section, and then we're just going to add event listeners for those. So on a key down event, we want to call key down handler. And what that's going to do, it's going to give us the event. And whenever a key is pressed, we're going to check the event key code. If the key code is 39, that means that the right key was pressed. So we want to set, that's just what the mapping is for the right arrow key. We're going to set the right press variable to true. If the key code is 37, that's the left arrow key. So we want to say that left is true. So that's our down key handler. On a key up handler, we have another function called key up handler. So whenever you release a key, we're going to check to see, did you release the right key? Okay, that means we're going to set the right press variable to false. Did you release the left key? We're going to set the left key variable as false. All this code right here, all this 20 lines, is literally just tracking the state of these variables, right pressed and left pressed. So we have those, but we still aren't doing anything with them. They're just variables right now. So let's actually update the main loop, the game loop, and do some stuff with them. And it's very simple. We are just, remember, every time we're drawing our paddle, we're setting the rectangle at the paddle x. Paddle x. And paddle x is going to be changing based on if left is pressed or right is pressed. So we've updated, if right's pressed, we want to update paddle x. We want to add the paddle dx to it. So if your right's pressed, it's going to move to the right 7 pixels on the next frame. If left is pressed, we want to subtract paddle dx. That's going to move it to the left 7 pixels of the frame. So that's it for this slide. Let's take a look at that. And bam, I can move it. You'll be able to see that even if I'm there, it'll go right through it. Well, we've got a problem still. If I just hold down right, we're going to go off the screen there. And that's not okay. That's a problem. So before we get to collision detection, let's fix that too. Because in a way, that's still collision detection. We want to detect if the paddle hits the side of the wall. And if it does, then we don't want to move it. All right. So new code for that. It's nothing crazy right here. We're just going to add in. We're just going to update those if statements we just had. So if right is pressed and the paddle x, which is the left boundary of the paddle, that'd be your guys' side over here. That's trippy. The paddle x plus the paddle width is less than the canvas width. So that's what we're saying there is if paddle x is over here plus the canvas width, plus the paddle width, so that brings us over here. If that is going to be greater than the canvas width, then we want to stop it. So we're just not going to update paddle x anymore. Same thing with the left. If left is pressed, but our paddle x, which is the left boundary, is that right? If it's greater than 0, let me try running this. Make sure that works. Yeah, that's right. Okay, I'm just not thinking. But if paddle x is greater than 0 and left is being pressed, then we want to. Oh, right. Okay. Brain fart. Then we want to move the paddle. Otherwise, if it ends up being less than 0, then obviously we don't want to move it. Okay. Okay, so we've got that going. Now we can actually do some collision detection. This is going to be our final big thing we're going to add to this. We just need the ball to actually bounce off of the paddle. So to do that, and this is all the new code we're adding, we're going to update an if statement we have, and we're just going to add in 3 conditions. Right now, the ball will only bounce off of this wall, this wall, this wall. We want it to bounce off the paddle too. And there's 3 conditions that need to happen for it to bounce off the paddle. The ball needs to be greater than the paddle x. It needs to be less than the paddle x plus the paddle width. And it also needs to be greater than the canvas height, which is down here, minus the paddle height, which brings it up here. So all those 3 things need to happen for the ball to change direction. And that's what we're doing here. We're tracking, this is the top wall check. We're just updating the previous if statement. So that one still stands. We're going to add the paddle check here, and this is checking if the y of the ball plus where it's going is greater than the canvas height minus the paddle height minus the ball radius. We want to take that into account too. If it's greater than that, if it's greater than, if the x of the ball is greater than the paddle x, so that's the left boundary of the paddle, but it's less than the right boundary of the paddle, which is paddle x plus paddle width, then we want to change the y direction. Otherwise, we don't want to. So let's take a look at that and see what happens. Can we do it? Can we do it? We did it. We did it. Now keep in mind too, this is not 100% foolproof, so if the ball were to come in at like an angle, for example, and hit the side of the paddle, we're not tracking that. You still lose that, and I guess the ball just decided to come back up there too. Okay. And that happened too. That's a feature, not a bug. Okay. The last thing I want to add is just a very simple kind of game over scenario, which the game over scenario is if the ball does go beyond the bottom wall, we're going to update the same if statement with an else if that says, okay, if the ball is going beyond the canvas height, then we just want to reload the page. You probably have some actual like, haha, game over type logic here, but that's okay. We're going to be nice. So we'll load up this page. And oh, we got a game over. Okay, so we've completed building single-player Pong using core.js. It's nothing crazy. You can see we are, with white space and everything, we're at, line 92. So it's nothing crazy. I do want to showcase. Originally, my tutorial was a brick breaker tutorial, which is kind of this thing. I kind of brought this down to something we could code together here with single-player Pong. This is using just core.js. And I want to say it's about 180 lines. And I kind of added fun little things of the ball going a little bit faster when you bounce. It's got a score. It's got lives. It's nothing crazy. But it's just a little bit more code than what we just did. And it's all using core.js. We won without even doing anything that last time. OK, but maybe you can build games using just core.js, as you can see, but that maybe that's what you want to do. I think this is a great stepping stone, but at some point you'll probably want to use some libraries. So, second question to win Wheeler District shirt. Who can tell me a JavaScript game library that you might use to build games? Yes? Boom! Phaser. Okay. And that's the one I was going to show there. Alrighty, let's just, there we go. Oh, we did it. We did it. Okay, so Phaser is a wonderful library, and I rebuilt this tutorial using Phaser, and it's just much better. Like, everything is smoother. We've got wobbles going on there. We've got different speeds. The ball is actually changing direction based on where it hits on the paddle. You can see animation. This is less code than the previous version. I think this was like 150 lines or so. It's just the interaction's much nicer. And when you build something, when I built this using Phaser, I felt like I was actually like doing game development. Like, I'm not just updating a canvas. Like, I'm saying, all right, here's a ball object, here's a paddle object. You know, and you have like hooks, like when the ball and the paddle collide, do this thing. You know, the same things are happening under the hood because I think this is canvas driven. But as a developer, it just clicks more in my head. Like, okay, when these things happen, do this thing. It's awesome, and I know. And Jesse's going to talk about Babylon, which is it's gonna blow my mind too. So I'm on the end, the home stretch here. I see we're right at noon. So my New Year's resolution was to kind of just build some game tutorials, and this is where I started. And the breakout games were part of these tutorials. So if you go to this page, just on the MDN website, this walks you through how you can get into this. This is literally the 2D breakout game I built that I showed you just a second ago. This is literally the Phaser one, and that's this one right here. I just went through the tutorials, and then there's a couple other ones you can go through too. They're fun and they're awesome, and they really teach you a lot. And I want to encourage you, if you're interested in this at all, to check these out. It's wonderful stepping stones. For me personally, you know, Clevyr Labs is getting into a lot of things like game development, so I wanna be on that train whenever that time comes. So it's been a fun journey for me, and it's still just the beginning. So I know that here's the link. You may not go to it, so if you don't ever come back to these slides, just Google game dev with JS tutorial, and I think it's the first thing. So that's all I got. I appreciate it. I'm the code boss. There's my blog website. That's it. Any quick questions? Yes. So the question was, do you have to redraw the whole canvas every time? It was easier in that example to do that, but no. If you were building a real game, you could do that, but you probably, because then that means you would have to redraw everything at the same time. So if you get to be more of a game development pro, you would probably just erase the things that actually need changing. And I know Phaser helps out with that, and other libraries will too. Good question.